Anything else with the last questions or specifics about last week? Or what is it?
It is the running day shuttle service for parking.
Okay. Yep.
Now your costs are different. The costs for different customer loads are, and it goes through and shows you which one through 8, and it asks what your marginal costs for each customer level, and if you are compensated $10 per ride, what customer load do you want?
Okay. So your marginal cost is fixed, correct? And we're trying to do one of those marginal benefit, marginal cost analysis. So what is the suggested answer?
It's a chart. And it shows the quantity, the number of passengers.
I'll pull it up here too, but I just wanted to hear it from you as we're doing it. What problem is this?
It's the first 4 2.
So you run a game day shuttle for parking services. Your costs for different customer loads are 1, 30, 2, 32. Oh, so this is how your costs are changing depending on the quantity of people you're carrying, right?
And I figured, the marginal cost for each.
Okay. What are your marginal costs for each customer load level? Okay, so you got the first part of the question, which is just doing the marginal cost there, right? So the marginal cost of the second is $2, right? Going from 30 to 32. So if you are compensated $10 per ride, what customer load do you want? Okay. So what is your marginal revenue per ride? $10. So that's fixed, but that's on per ride, not per load. Correct?
That's okay, that's what I was wondering.
So you run a game day shuttle service for parking services for the local ball club. Your costs for different customer loads are that schedule. What are your marginal costs for each customer load level? If you are compensated $10 per ride, what customer load would you want?
So per ride is person?
That's not my interpretation of it. I'm thinking the ride. Now, what is the suggested answer? That's how I'm reading it. Or is this? Yeah, this was the question.
Since the suggested answer, since the marginal revenue is the price of $10, you will serve customers up to the point where marginal cost is greater than marginal revenue, or you will serve 7 customers.
Yeah, they're doing total revenue by person, right? Quantity there, see?
Yeah, they are.
So they're doing it not by ride, but by load, or not by, by load.
So it is $10 per person, basically. Yeah. Okay. But so what would it be if it was $10? So this is a good way to take these questions a different direction if you did interpret it that way. After seeing the way they did it, if it was the ride was $10, how many people would we say maximum per car, so to speak, right? So we could say, well, we don't allow more than X per car. Because, you wouldn't be making too much money here since the cost with one person was even 32. So it kind of makes sense as we get deeper into the question here, right? I mean, you wouldn't be you wouldn't be making any money even on the first person. So, but at the margin, since we have, so we got total cost. So we can see that the most of this is fixed costs, right? Because we got the marginal is so low, 233 for each additional person. It's mostly, and that makes sense with the cost of the car and insurance and whatever. It's all fixed rides. So if we had, what was our optimal here? Was 7. So at 7, our marginal cost of, so they were just trying to catch you between 9 and 11, that would be, you wouldn't be quite, so this is where we get into one of those lumpy things, like is it worth it to go from 9 to 11, or should we stop somewhere in between? Well, we don't have 7.5 people, we don't have a half person, right? So we kind of have to make that decision. And so what would be the problem of jumping up to the 8th? Yeah, we'd lose $1. So we kind of found, because of the discreteness of the problem of the numbers that we're working with, that it'd be better to stop at 9. And so we're, you know, graphically, like we were starting to do last time, if this is the marginal cost and the average, I'm sorry, I want to put marginal revenue. So we got a marginal revenue of $10, and we got some sort of marginal cost going up. It's like we're kind of stopping short, where the cost of the revenue generated by the last one's a little bit higher. It's like we'd like to go a little bit more, but by going more, we end up going to the 8th, and I put 9 here, but I meant to put 7. By going to the 8th person, we end up having this kind of outweigh this is one way to look at it, right? And that's why we start to get that dip. And you can't really always figure that out until you just lay out the numbers when you have these discrete problems, and that's where these tables putting on our schedule goggles kind of come in handy. Okay, is that good?
Yes, thank you.
All right, anything else? All right, so for today, we are looking at some stuff here on demand. So simple pricing, I'm just looking right at the syllabus here, week 3. So consumer values and demand curves, marginal analysis, price elasticity. So we're going to do some number crunching. And we want to start with the demand curve, which we've kind of just loosely maybe referenced at this point, but haven't studied that closely with. But it was in your MBA, what do we call that thing? Not primer, but
MBA math.
math. It was in your MBA math, that demand curve. All right, so demand curve. What is it? What's your hunch of what it is? I didn't grab my water today, did I?
The chart shows the relationship between price and quantity.
Okay, good. And what is that relationship?
The customer demand.
Yeah, what is the relationship between price and quantity for customer demand?
What it is they're wanting.
Yes, and so what is that relationship then? As price goes down, what happens to their behavior to purchases of quantity? More, right? So this is all just gut feeling stuff. So if price is up here at $10, then consumers buy 2 units. If price falls, maybe it even gets cut in half here to 5, and it raises to something. Maybe it's all the way up to 10 units now. Could be anything. So there's 2 points that we may have observed in the real world where price was set, we sold some. Price was decreased, and we sold more. So that was the law of demand. Now, what can be deceiving with this is what? When we say price was 10, we sold 2, we dropped the price, and waha, we sold 10. What are some things that might have caused that quantity to change other than price?
Like a seasonal.
Okay, could be something seasonal, good. Some seasonal change, yeah. What else?
Natural disaster.
Okay.
Talked about last month.
Yeah, natural disaster would work, yeah. What else? Government, yeah, some of those external things we talked about. That was more related to the company, but you're right. It falls right in line with with the consumer too. One of the big ones is income. So the point is so if at a price of 10 we used to buy 2, prices fell and we bought a whole bunch more, well maybe if income hadn't changed and price fell to 5, we would have only bought 4. But at the same time the price fall happened, we got a new job and our income went from $20,000 a year to $40,000 a year. It's like, woohoo, man, I'm going to buy a whole bunch more now, right? So our purchasing behavior is dependent upon a number of things. The most important thing, I think, the economist would argue, is indeed the price. Price is kind of the great equalizer in purchases. It's the thing that changes according to different changes in the condition of the economy or otherwise. And so we kind of, because price we believe is so important, we measure it here and map it out. So if we make a bold statement that price falls from 10 to 5 and I increase my purchases from 2 to 4, there's 2 special Latin words that the economist puts on the end of that, and that is ceteris paribus. Ceteris paribus, holding all of the things constant. So the law of demand, the law of the land in demand land, the law of demand is as the price of a good or service, we'll throw that in too, as the price of a good or service increases, parentheses decreases, so it changes. As the price of a good or service increases, the quantity demanded, QD, I'm going to put Q subscript D, I guess I was going to put a little parentheses P up here for price. The quantity demanded decreases. Price goes up, people buy less. Price goes down, people buy more. So parentheses increases. I mean, in shorthand notation, we just say price goes up and people buy less. And price goes down and people buy more. The law of demand. Well, as I was saying, that law, written as it is, I would have to deduct at least half credit if this was your answer on a test or something, because it's missing the most important thing. This law is complete BS if it doesn't have those 2 Latin words at the end of it. Because this doesn't hold at all if we allow other things to change in the economy. So if I drop price, let me go the opposite direction. If I increase price, the law of demand says you're going to buy less. But if I increase price 10% and I double your income, you might just buy more, right? So it makes absolutely no sense in a scientific way, if you will. And that's what economists, this is kind of the positive analysis as opposed to normative analysis that economists do. This is kind of a scientific research lab experiment that we found is true in the data if there is ceteris paribus, holding all of the things constant. All other things constant. Things like income. Things like the price of related goods. So if the price of bowling has always been about $5 a time, you think, hey, let's go bowling. I'm pretty consistent, but the next time you go bowling, bowling shoe prices have doubled from $2 a time to $5 a time. And you don't have your own bowling shoes. The effective price of going bowling has gone up, right? Without the price of bowling changing, the price of the actual bowling lanes or whatever, that stayed at 5, but the price of a related good went up, causing you to not bowl as much, potentially, to reduce your quantity of bowling, right? So under these two categories, there's two things going on. So since I left off with the bowling shoes, goods can be complements. And I'm not a stickler on spelling in general, but I do want you to, don't put the I here, like, oh, you look nice today. That's a compliment. This is a compliment in terms of it completes the package. And so if you remember that terminology, again, not so much on the spelling exercise, but more on the visualization of what you're talking about, when we use two things together, peanut butter and jelly, fishing poles and fishing line, bowling shoes and bowling, tennis rackets and tennis balls. I mean, it's all over the place, right? And that's what the real good companies out there are able to bundle things together for us, right? They get that. And we're going to spend actually a lot more time, not even more so today, but in future chapters, talking about the bundling of things and why we do it. So complements are goods that are work together in consumption. And I'm going to just put my G&S notation here. Goods and services, by the way, so those could be combined together, right? We do that all the time when we go to the restaurant, how good a service we got along with the actual food we got. So goods and services that are consumed together. So, PB&J, peanut butter and jelly, bowling shoes, bowling, tennis racket, tennis ball, compliments. What's the other way goods can be related that might impact your purchases? So let's stick with bowling. So the price of bowling stays the same. What are some other goods that, if their price had changed, could decrease the number of times you go bowling? So what are some other goods that might impact the quantity of bowling that you buy? So on a given night, you're with your friends, you're like, hey, should we go bowling?
You need to go bowling?
What do you mean by that?
Like, a lot of bowling always has a beer and a concession.
Okay, yeah, so you're still thinking of probably the complements there. So things that would go together. Yeah, so other than those things. So you're with your friends, like, hey, should we go bowling? Maybe we should go up to Lawrence and, I don't know, what do you think we should do? What might cause you to be a decision-making thing? What's that, cash? Because cash would fall into the income category.
The cost to get there.
Gas.
Okay, possibly. That might be related to the bundle if we're not holding that constant on the amount of travel time. That's why I said kind of going up to Lawrence. So we go up to Lawrence, it's a pretty big city. We could go bowling. I'm trying to lead you a little bit. We could go bowling or do something else, right? So that's going to cause us to do something. So if we all of a sudden learn that the theater, as we're driving up to the bowling alley, and the theater says, tonight only, special show, half price, right? So they cut their price. Maybe we turn to our friends and say, hey, I've been wanting to see that show, and it's half price today only, let's do it, right? So the price of a substitute, things that we would use in terms of the other. So we got complements and substitutes. So these are goods and services that can be consumed instead of the other, or in lieu of, or it's kind of an awkward thing to write. Instead of, so one or the other. One can be substituted for the other. Let me come back up to income for a moment. So if our income goes up, do we tend to buy more or less? More. All goods? Is there anything that you guys think you might not buy as much now that you're poor college students? I don't know for sure that you're poor, but usually even in grad school there's an element of poorness, but maybe not. That once you're done, if you're making more money, that you'll buy less of? Maybe think back to your undergraduate days if you are indeed rich right now beyond your wildest dreams. Okay, like what? Yeah, ramen noodles are a classic one, right? So we tend to avoid maybe ramen noodles. We used to buy hot dogs a lot more often. We still like a hot dog once in a while, but we don't buy them nearly as much as we did when we were undergrads, right? Now we buy steaks if we're doing real good, or at least a hamburger or something. So with income, we have two categories too. Those things that economists call normal goods, and that which we call inferior goods. And so with a normal good, an increase in income leads to an increase in the quantities that you're buying. With an inferior good, an increase in income leads to a decrease. So these are the ramen noodles. The normal goods, or most goods, are normal goods. Okay, so we got a few more things to add to the list. Let's put in here tastes or preferences. If something's cool, if something's in style, if we've been told by experts that something's now dangerous for us, we might cut back on it. All right, so these are the main ones that we want to focus on. Again, we're holding all other things constant, so there's some other things here that, that could play in a role, but for this chapter, these are the main ones that we will focus on with elasticity. So I could spend more time on this, but I think I want to just kind of leave it there. What does that do to this demand curve then? So coming back to this example, if there is an increase in income, holding all other things constant, what happens to this red line? If there's an increase in income and this good, this Q that we're talking about is a normal good, what happens to that red line? Straightens up. So kind of, I brought my golf club today for just these types of circumstances. You want it to do this?
No, the other one.
Flatten?
Flat out, yeah.
Okay. With income going up and it being a normal good? Everybody agree with that? So let's go ahead, David. So you want it to flatten, so at $10 at higher prices, now that you're a fat cat with more income, I'd be wanting to buy less at a higher price. And then at lower prices, then you kind of buy into it. I used to want to buy 4 units at $5, but now that I'm a rich fat cat, I'm going to buy more. So when price is high, and you were willing to, at your current, let me put a little more meat on the bones here, let's say you're making $20,000 a year, So at an income level of 20,000, at $10 you used to buy 2. At $5 you'd buy 4. Now you're saying at $10 I'm going to cut back to 1 because I'm making 40,000 a year. So at high levels you'd buy less? You'd buy more, right? So if that happens here, at $10 we used to want to buy 2, but now we're going to buy more. At $15 we used to buy nothing. It's like, wait, this stuff's way too expensive. Now that I'm making $40,000 a year and covering all my main bills, I'm going to buy this amount. At low prices, I used to buy this much, now I want to buy this much. At $7.50, I used to want to buy this much, now I want to buy this much. And so if we map out this line, we have a new demand curve that relocates itself to the right. It does not have to be a parallel shift, but I wouldn't say we have enough information, Donald, to know whether it would flatten for sure or maybe even get more inelastic. It depends on the nature of the good. So we don't know for sure if it would flatten. But the main point I was trying to do there is it would kind of violate the law of demand here if this thing would go in like that. So it's going to push out. You're absolutely right. It could do a little wiggling. Could get nonlinear is another thing. The real curve, it might be a curve actually, something with a little roundness to it. So it could be a number of things as we go. And so then we use some more sophisticated statistical techniques called econometrics is what economists use. It's really statistics applied to economic problems. We call econometrics, and we can kind of measure that. And we're going to do, well, we're not going to do full-blown econometrics, but we'll talk a little more quantitatively about it here in a little bit. Okay, so did you see the shift though? That's the main thing here, is that holding everything constant, like our income, we have this law of demand. Drop price, you're going to sell more. However, we got lots of other variables that are important to the buying process that we're holding constant when we make that claim. If one of these things changes, then we're going to get movement over here. So if this was the demand curve for, let's go with our bowling shoes. Hey, there he is. If this was the demand curve for our bowling shoes, I meant bowling game. The bowling game, I was going to go with our exact example. Bowling game and bowling shoe prices went up. So this is the quantity of bowling games. Price of bowling shoes went up. What happens to the demand for bowling games? Goes down, right? So it's going to move this way. So these are all things that will shift the curve. These are demand shifters. Yeah. It is. Yep. Yeah. I mean, you might have even been wanting to do more. I mean, how we respond to it, if we were able to change it, or then we get into packaging. Like the company has it set up, and this is where we'll get into more fun stuff down the road. So I don't want to jump the gun too much, but buy 3 and pay $15, but today only buy 5 and the price is $20, right? So we bundle the quantities together to try to get more out of people at the margin. And last time we talked about diminishing marginal benefit, I think. And so that plays into that, right? So that, well, I really only wanted to buy 3, but because people don't say this to themselves, the extra 2 don't give me as much happiness as the first 3. The first 3 give me more happiness than the next 2, but since you dropped the price for me, that sounds like a bargain, I'll buy it. right? And so we get people to kind of play into that. All right, so all of these things here are demand shifters. All right, so to tie this into really more of the meat and potatoes of this chapter is on elasticities. And so with the demand shifters, along with the price, we can quantify the magnitude of the changes. So with demand shifters, we kind of stay in this goes up realm. With increase in demand, or increase in income leads to an increased demand. Kind of our beginning steps. If we go to the CEO of Pepsi, and she asked us, I think it's still her, I can't remember her name, Indira something, Indian woman. We go to CEO of Pepsi says, hey, what's going to happen if I decrease the price? And we say, I know, you're going to increase the number of units sold. She says, I just paid you $5,000 for you to tell me that, and you didn't know we were actually getting into the consulting business. But she's smart enough to figure that out on her own, right? She had Econ 101 too. So what she wants to know as an economic consultant is that if she raises price by 10%, what's quantity going to do? Is it going to go up by 2% or 20%? Right? So there's a balancing act there that we're going to take into account because not all price changes work the same. There's a difference with its impact on total revenue. Now, let's back up to last week or even the week before. What is the objective of the firm? Our assumption anyway? Good. You got that one down now. All right, so profits equal equation goggles. Total revenue. Great. Total revenue minus total cost. We went through the whole business last week of we can break this into fixed costs and variable costs. We talked about marginal costs. We looked at marginal revenue, the incremental changes in revenue. All right, so now we're going to tie in these and quantify the demand curve with that. To do that, let's see, let me start off first with just a basic graph. So there's the demand curve. Let me pick off 2 points here. Let's go 10 and 8. $10 to $8. And let's say that lines up with 100 and 120. So there's our 2 points along the linear demand curve. And we have a formula for elasticities that helps us measure the magnitude of changes. And it's the ratio of the percentages. So we're going to start off with what we call the price elasticity of demand. So we're just looking at prices. So the price elasticity of demand, which I'll use this notation, a little sigma subscript d, the price elasticity of demand. It's a ratio of the percentages of changes. So it's the percentage change in quantity demanded divided by the percentage change in price. The percentage change in quantity demanded divided by the percentage change in price. You might want to come up a little closer. Was it the seeing it too, or?
Yeah.
Why don't you come up a little closer, because I'm going to get even smaller than that. And on this particular spot, I don't like to write small if I don't have to, but we're going to do little formulas here, get a little quantitative. Now, yeah, did you get the email? Because I didn't know if you had checked. I saw that you had added last week at some point.
Yeah, I got added. I had checked the announcements on Blackboard, but I guess I just missed it. I saw the Tuesday one.
Well, no, I just sent the reminder out today.
Oh,
I thought
okay,
maybe
no,
you
I
would have checked with Peyton or somebody when. Okay.
I've been on campus since I got a recruit today, but
Okay.
I just got home, was opening up the Blackboard and shot it there.
Okay, cool. I'm glad we got on to you. So percentage changes. How do we figure that out? Who remembers math? Intro to math of the percentage change in a variable x. Anybody remember that one? If we do, what's that? It's not necessarily to 100. If something's priced at 100, let me press you on this, and we do a 20% increase in price, what's the new price? 100 and more than that? 20. So 120. All right, so anybody remember new number minus the old number divided by the old number? That's the way I remembered it. But so that's our percentage change in a variable, in any generic variable. I just like to take the new number minus the old number divided by the old number. So if prices over the last year had climbed from 100 to 120, 120 minus 100 divided by 100 gives you the 0.2, remember, right? And slide the decimal spot over a couple spots, we get 20%. All right. So over here, to confuse you a little bit, not really intentionally, but just by the design of this, we're going to do something a little different than the way that percentage changes are normally calculated. And it has to do with what I just said. If I was to take this formula and look at a 20% decrease now, we're starting at 120, and we're going to do a 20% decrease. How much of a decrease is that in terms of dollars, applying this method? So, what's that? A little more than that. Because we're taking 20% of the 120, right? We're starting with 120. 20% of 120, let's see, 10% would be 12. 12 plus 12 is 24. 24 from 120 is actually 96. So it's kind of weird how percentages work depending on what number you start with. So if the old number is the 120, then I get 100 minus 120 divided by 120. What does that actually give me then?
Would it be 96?
Well, no, I just wanted to do, if we put the same number in here of 120 minus 100 divided by 100 equals our 20%, right? But if I do the opposite and I say 100, I am flipping things on you a little bit here. 100 minus 120 divided by 120, what did you get, David?
Negative 17%.
Negative 17%, right? So it's a different percentage change. So it all depends on what we're using as our anchoring points. I just wanted to kind of highlight the confusion of going up or down is the main problem we're trying to address. Here's how we're going to address it. It's not too big a deal. We're going to take the average of the two. Instead of taking either endpoint of the old number, the new number, let's just average them, and then we're going to get the same answer every time, right? So we're going to divide by 110 in this case is the average, and we're going to do the same thing with prices. So the formula up here that we use, and this is called the ARC method, and your textbook goes through this too, is the new number minus the old number divided by the average quantity. And then it's the new price minus the old price divided by the average price. Okay, so let's go ahead and get your calculators out if you don't have them already, or if you're using your laptop calculator, that's probably fine too. So here's the average of these two is 9. The average of this one's 110. So let's do a price change. Let's start from $10 and move from point A to point B. So we're doing a price decrease. We're dropping price, so then be careful about your new number, old number business, right? We're dropping price from 10 to 8. Sales went up from 100 up to 120. So very carefully go through and follow this formula and calculate the elasticity number. And make sure, if you hadn't done so already, if you wrote this formula down, make sure that you say this is the way we used to do it, but not in econ class. So we need to change that to the average for econ.
Russ, what was the starting point for us, the new and the old?
A to B. Oh, so we'll just say that this is, yeah. We could use little zeros and ones or ones and twos. So I'll go ahead and do that because you might as well get comfortable with that. So P1, and this is P2 if you want to think of it that way. And that's associated with Q1 and Q2. Get an answer, let me know what you got. You'll have to get your calculators going. And you know, before you jump into your calculator, lay it out on your paper so I can see it, that you got what you're doing. Good, yeah, just something like that. Just kind of write the numbers in their right spots. Don't be shook up by the negative sign. You're on the right track. Not sure if that's what you're pausing on. Okay, follow this formula exactly. So you got Did we get a number yet? Number? No? Did I screw up? Sometimes I screw these up.
I got it. 18181.
What'd you get?
0.8181.
0.8181.
That's negative.
Ah, gosh, I'm glad you said that.
Negative 81.
I was going to pick on them and say that that answer was absolutely, completely, totally wrong, because there is a negative sign. So that negative sign turns out to be important in some cases. What bears out the negative sign? What law tells us that we have to get a negative sign with this equation? What law of economics that you may have heard of not too long ago gives us that negative sign?
The diminishing
Nope, not that one. Even more recently, we talked about this law. Look back in your notes
Oh,
from about
all of them.
good, yeah, the one that we just talked about 50 minutes ago. The law of demand gives us that one. As price goes down, quantity goes up. If price went up, quantity went down. Those two variables are negatively related to each other, always. So we're always going to have a negative sign pop out of this equation. And to further confuse things, maybe, only if you don't remember the law, is when we talk about elasticities, we usually refer to them in terms of their absolute value, because we all know that it's negative. So a couple comments then to make on this. So a couple notes. So note, the elasticity of demand is less than 1 due to the law of demand. The elasticity of demand is less than 0. Sorry, I was trying to get a negative sign out. 1. Less than 0, it's negative. That number's negative due to the law of demand. Since we all know that, since we all know that, economists often refer to the elasticity of demand as its absolute value. So that we're not always saying, oh, it's negative 8.1. Well, I calculated that it was negative 8. Instead of using the word negative, so literally, like when we verbalize it, we're talking price elasticity so that it's negative. I think it was mostly invented to confuse students, but that's the way it works. I didn't make it up. Okay. One other thing that I'll let you prove to yourself if you want. Your book gave slightly different, even kind of simpler formula for this. I don't even know if it's that much simpler, but so my other note here, note number 2. Note number 2 is that the elasticity formula can be the difference of this. So in book, it can be shown, I don't know if they do this in a little shorthand note or not, that if we do the new number, and let's see, the book actually, I'm going to go ahead and use the 1s and 2s. Doesn't really matter which direction. So Q1 minus Q2, this is exactly, I think, how the book has it. Q1 plus Q2. So if you take that thing and then calculate P1 minus P2 over P1 plus P2. I just don't want you to be confused when you see that formula in the book. You can actually prove it to yourself that the averages will end up looking like this if you do a little bit of math with it. And it's just because, how do we find the average? Well, it's really 10 plus 8 divided by 2 is 9. 100 plus 120 is 220 divided by 2. So all we've done is we've mixed out the 2's in there. So it's really the same formula, but it looks a little weird. Okay, so everybody okay so far with this? Got at least the feel for it? Let me interpret this first then. So interpreting an elasticity, especially for you guys, to me is probably even slightly more important than calculating it, although I don't know if I'd necessarily weight it that way on a test or something, so sorry about that. But the interpretation for an MBA class, since you're not getting much further in economics, is super important. So there's an easy way to interpret this number of 0.81. Is it 0.81%? Is it 0.81 bowling shoes? Is it $0.81? What the heck is it? 0.81. What is that 0.81? Anybody look at this, the way we calculated it. Anybody want to take a stab? Because we should always be thinking about the units of what we're dealing with. And 0.81. Randy?
What did we calculate? Did we calculate the price?
Yeah, so, but it was the percentage change in the price, right? So if you focus in on this part of the definition, that's what flowed all of a sudden into a 0.81. So we're saying the elasticity of demand is 0.81. And my question is it $0.81 or bowling games or percent or what is that sucker? Right answer. You guys are doing good. It's a unitless number. So your silence was golden this time. All right, so it's just the ratio of two percentages, so it actually has no units. So it's all relative, one relative to the other, as we'll see, and that ends up being kind of important here. So this is a unitless number. It's a ratio, a unitless number. Still has important meaning, it just doesn't have any units. So I wanted to bring that up first before we get into the interpretation. And so for the interpretation, the key is to look back to the original formula. So you need to have this part of the formula memorized. Some questions will stay in percentages. Other questions might be more like this, where you have to actually crank it out. But sometimes we might have a question that says, suppose demand increases, back to my CEO of Pepsi example, suppose price increases or decreases by 10%. And we know that the elasticity of demand is 0.18. What is the effect on quantity? You could do a little algebra and solve for that, right? So, so don't forget that interpretation, but or that formula, don't forget. And it also assists us with the interpretation. So let me rewrite it here. The elasticity of demand is equal to the percentage change in quantity demanded over the percentage change in price. And in this case, it was equal to negative 0.81. I'll even leave off the other 81 for now. How can we turn any number into a fraction? There's that one little secret thing we can do that makes this really easy. How can we turn any old number, you give me any number and I'll turn it into a fraction for you without losing the actual value of the number? Divide by 1, right? So divide by 1. So we can take any number and divide it by 1. So this is strictly for remembering how this interpretation goes, because now look at what we got. The 1 goes with the percentage change in price. The 0.81 goes with the quantity demanded. And so our interpretation becomes pretty easy now. A 1% increase in price leads to a 0.81% decrease, don't forget the negative sign, in quantity demanded. So interpretation for this one would be a 1% increase. Now I won't write the parentheses decrease, but that goes without saying too, that it goes both ways when we calculate elasticities. A 1% increase in price will lead to a 0.81%, not 81%, but 0.81%, okay, special note to that, decrease, there's the negative sign, go in the opposite direction, in quantity demanded. A 1% increase in price leads to a 0.81% decrease in quantity demanded. Now the CEO of Pepsi is happy to cut you your check for $5,000. That's the type of info they wanted to hear from an economist trying to quantify things. I mean, David, up in admissions, I mean, that's the type of thing that would be priceless, right? If we cut tuition, how many more bodies will we get? Well, if we're going to get 40% increase in students here from a 1% tuition cut, should we do it? Heck yeah, right? Students aren't that price sensitive, by the way, to it, so that's why we don't do that. The data doesn't show that. But if we cut tuition by 1%, and we only gain 0.1% students, like we get one more person here or something, then that was kind of dumb to do because we lowered the price for everybody else. All the people that came here that would have came here anyway, they kind of got a free cut in price. We already had them. We didn't have to give up anything for them. So that's the game that we're playing with elasticities. Okay, so question on the interpretation. All right. Another thought exercise for you, if I haven't given you enough already. Suppose we cut price again to 6. What is this number? What's the new quantity? I'm not playing any punches here or anything. What is the new quantity? If this is a linear demand curve, 140, right? So linear demand curve, rise over run business, down 2 over 20, down another 2 over 20. So this would be 140. Now, the elasticity of demand at, if we want to think, because we did it with these averages at 9 and 110, the elasticity of demand at this point along the demand curve in absolute value was 0.81. What is it here along these new points? 0.81? Greater than 0.81? Less than 0.81? So you were absolutely right, rise over run. Let's just do it. I know it seems like it might be kind of a no-brainer, but go through the pain of the formula again, just like you did earlier. Yep, for P2 to P3. And as soon as you get the answer, shout it out. First person with the correct answer gets an extra credit point.
We got 0.5384.
0.5384. Now what?
This is the negative bar.
Oh, no, that's not obvious. You're lucky you snuck that in there. I don't know the right answer, by the way. I haven't calculated this one, so I'm going to rely on you guys this time. David thinks we got something different, and it's something less than 0.1, right? You said 0.53? If you get another answer, just tell me what it is. Don't be bashful. You got the same too? Okay. Donald? Got the same. Okay, so we got 3 the same. All right, so it sounds like we're looking good.
I'll see what happens.
So we're at kind of 7, and 130 is kind of our anchoring points here. And so we get the absolute value of the elasticity is 0.53. Let's call it 0.54. I guess I didn't round that one, but.
I was saying I got the same as the previous.
Oh, you got 0.81?
Yes.
Oh, okay.
I got 25,
You got you confirm that. All right, so David's correct, I think. Again, I didn't crank out the numbers, so you get the extra credit point, I think. If we got, Donald, you got that too, didn't you? Because it's not the same. I do know that. It does change. In fact, it changes everywhere along the demand curve, depending on where we evaluate it at. Why?
Yep, I got it.
You got that too? Okay. Randy, did you figure out what you did?
No.
Let's see, let me get David's point down here so he doesn't sue me for not getting it. Yes, quantity went up, but what happened to the percentage change? Did you write it out?
No, I didn't.
Okay, always write it out first. So that's your first problem. Make sure you write out the whole equation on paper, because I will give you partial credit even if you screw it up on the test. So, because then it's kind of easier to dissect what you might have did. So I'll come back during the break. I'll look yours over. What's the key thing of why this thing's changing as we move along the demand curve? Does anybody see that? You might not have broke this apart on your formulas here to see it real clear. Let me put it to you this way. If we pick a point that's way over here, and I go from a quantity of 1 to a quantity of 2, what's the percentage change in quantity, roughly? Not worrying about averaging and stuff. If I go from a quantity of 1 to a quantity of 2, what's the percentage increase? 100% almost, right? Again, kind of ignoring the average thing. So we got almost 100% increase. And if I come down here and I move from 140 to 141, how big's the percentage change? Bigger or smaller than 100%? Way, way small, like less than 1%, right? So as we move along the axis, the percentage changes are changing for the same unit change. Like down here, these are big percentage changes for a 1 unit change, and here they're very small. Same thing's going on with the price axis. Up here, if we move from $9 to $10, that's like roughly a 10% change in price, right? But if I go from $1 to $2, that's again 100% change. So if we're down here, price changes percentage-wise are big and quantity small. Here, vice versa. And so everywhere along the demand curve, we have that happening. The elasticity of demand is different along a linear demand curve. All right, so time to get to, so this was right. All right, so we got 2 points now evaluated, this point and this point. And so the key result, maybe I'll just say the elasticity of demand is different at various points along a stationary, non-shifting, just trying to get that, stationary demand curve. Stationary linear demand curve too. Oops, linear. It has to be a straight line to get that perfect result. Okay, time for my favorite graph in economics. This is my all-time favorite. So you know this one's going to be important. I like. I want you to graph two things stacked on top of each other. So we got two. Boy. The cameraman's failing me here. There we go. Now we're back in action. All right. The top graph, we're going to have the demand curve. So just put price, quantity, and go ahead and make some sort of demand curve that touches both the axes. It doesn't have to be, it can be tilted a little bit, it's no big deal. And that'll be our demand curve. And then on the vertical axis down here, we're going to measure total revenue, which is what? Putting our equation goggles on, we had profits equal total revenue minus total cost. The the total revenue equation in its simplest form for a single product company was what? Quantities in there combined with price. Price times quantity, right? So boom, boom, price times quantity. So total revenue is equal to price times quantity. On the horizontal axis, we've got quantity. And the reason I stack the graphs like that is that they totally match up. Like if this happened to be, 1,000 or something, then this is 1,000 down here. Now, as the price goes down, down arrow on the price, what happens to quantity demanded according to the law of demand? Goes up, right? Price goes down, quantity goes up. And herein lies the issue. If the up arrow was really little relative to the price arrow, then what's going to happen to total revenues? Are they going to go up or down? Down. So if the price arrow is relatively big to the up arrow of quantity, then there's going to be a downward effect overall. Whereas if the decrease in price leads to a big change in quantity, a big arrow, then the quantity effect is going to outweigh the price effect, and we're going to have revenues climb. So we've got that relationship, which is nonlinear, going on with revenues, and that gives us a total revenue function that looks something like this. Now watch me draw this. This is a little cheat thing that professors learn over time. If you bisect this line segment right in the middle about, wherever 500 would be, I guess, using since I put 1,000 up there, and then go up to the demand curve, and then I just like to come down to here and mark a point, and then draw a parabola, which is that upward or downward facing U, and make it look like that. That is the total revenue function. And what's neat about this is it shows how it's related to demand, and what I haven't shown you yet is ultimately how it's related to elasticities. What is happening at this point here? I mean, how would you describe that, the way I kind of mapped it out? If you were looking at a function like this, what would you say goes on at this point? It's the highest point. Total revenues are maximized, right? Is that what you said? Our maximum at this point. Now, are we looking to maximize revenues? Okay, so I want to make that clear, right? That's not our objective of the firm, is to maximize profits, not revenue. So, but nonetheless, this is the revenue function of price and quantity as it relates to demand. That maximum point is where the elasticity of demand is equal to 1. We say that demand is unitary elastic at that point. That doesn't make it the optimal point because we're looking to maximize profits, not revenues. But nonetheless, that is the way the numbers work out for revenues. Over here, look at what goes on. If I move from a point like A to a point like B, I'm doing my price decrease, right? So a decrease in price leads to an increase in quantity, just strictly law of demand business. But point A corresponds directly on the total revenue function with, let's call it A prime. And B corresponds with B prime. And now we're showing an important thing going on here, that as price falls over this range, revenues go up. The cash register is getting fuller when I cut price between A and B. Now, as I cut price over here, if I was to pick points C and D and try to make them about the same distance so that the numbers in absolute terms were the same, maybe I'm cutting price $2 or something in each case. Point C corresponds with C prime and D prime, and we quickly see that a cut in price over here leads to a decrease in money in the cash register. Revenues actually fall. So while the law of demand holds that a cut in price will lead you to sell more, it doesn't always mean that you're going to have more money in the cash register at the end of the day. Okay? The pile of money, so to speak, is going to start to fall. All right, I still have a positive pile of money, by the way. So this is still a positive number. I still have money in the cash register is my point. I just don't have as much as I might have had I actually gone the other direction with it. And I would have sold less. Okay, so what's going on with these ranges? Over here, in this whole area, the elasticity of demand in absolute value is greater than 1. Demand is said to be elastic. It's the elastic range of the demand curve. Over here, the elasticity of demand in absolute value is less than 1. Demand is said to be inelastic. Or this is the inelastic range of the demand curve. So, when Indira, I almost want to look that up. I think that's her name, but I'm not quite right. So, CEO of Pepsi comes to you and says, "Hey Russ, I want to know what if I decrease price, how much more I'm going to sell." If we find out that the elasticity of demand was 0.81, when we come back to that little wrap-up time with our executive summary, what should we tell her to do? Raise the price, not lower it at all. So we're going to come back to her with some really good news. We're going to say, hey, if you raise your price, you will actually increase revenues because we found that your demand for your product is relatively inelastic. In other words, consumers aren't really responsive to price changes. There might be some other variables that are more important, but for some reason, they're like, price of a Pepsi is $1, price of Pepsi's $1.10. I don't really care. I'm going to buy the Pepsi at the cash register or whatever, right? So they're kind of insensitive maybe to price changes, which is really good news if ultimately she cares about this equation. Why? If she's told to increase price and you will raise revenue, that makes this equation for sure a no-brainer to do. Why? If she cares about this, which I know she does.
Higher revenue is just going to lead to higher or total profit as long as cost is low.
And that's what I want to think about here is the cost.
The cost is fixed.
No, it's not necessarily fixed. As I decrease price, what happens to quantity? I'm sorry, as I increase price, what happens to quantity? What happens to cost? if they're not all fixed?
Variable costs, and obviously if you're producing less, it's gonna be less variable costs you're gonna have.
Right? So costs are actually going to go down. You'll still have your fixed costs, but you'll avoid some variable costs, the costs that are associated with each additional unit of production. So if I cut back my sales from 140 to 120, that's 20 units of product that I'm not having costs on, and the remaining units that I did sell, the 120, actually put more money in the cash register than what 140 was doing. So it's kind of like a total no-brainer to raise the price a bit. Okay? And I'll tell you what, that I swear that's one of the most common mistakes of especially small business. Big business, sometimes they can afford either economists or other people that are pretty savvy with that. But small business tends to cut price too much, and they price too low to begin with. Is another problem with a lot of small business. They price their product too low to begin with. And then they think, oh, times are tough, so let's have a sale, let's run some coupons, and they're cut. When the answer might be to better combine other things. Maybe it's not as easy as just raising your price because you've already blown it in some other areas, but to kind of repackage your product maybe and actually up the price with some other services or other enhancements. Those are some of the topics that we'll talk about later. So this chapter is important in kind of setting the foundation so that you guys really understand the importance of these elasticity concepts and how it relates to profit maximization overall. Okay. Let me see. I just want to make sure I don't. So I would just kind of memorize this little graph because it wraps up a whole bunch of questions all in one that could be on a multiple choice problem or it could be otherwise. This isn't too bad. You should have this memorized anyway, right? This isn't too bad. You got this little humpy thing. Remember that those two are connected. But look at all the stories it tells. So if I came at you and I said, suppose that demand is relatively inelastic and you decrease price, what do you predict will happen to revenues? Well, if demand is, so then you kind of go through this graph roughly. We decrease price, demand is relatively elastic, total revenues are going to fall. And you kind of got the immediate connection of, if you were to work through that with your equation goggles on or through memorizing other things, it'd be kind of hard. So this is one of those where having your graphing goggles on, a picture's worth 1,000 words type of thing, I think you get a lot of meat out of this particular graph. All right, so let's take a break there, and we'll come back and talk a little bit more on elasticity, and then we've got some other stuff to talk about in the next chapter. This has all been pretty much